Hi everyone, my name is Viola. I'm a security engineer. I'm also a platform engineer and I work a lot with IAM and access control. My primary focus these days is the cloud, with a platform that we build to foster a more secure access control, working a lot with IAM and credentials and OAuth 2.1 now. And it's going really great until the point where you see companies misusing the settings and creating different scopes that they're not aware of, and it just drifts at some point. So today's talk, I wanted to dedicate to the engineering workflows, but as a platform engineer, I'd really love to talk about the agent involvement in that. So before we go further, here are my socials, so my LinkedIn, my website, and the AWS services I provide. So you can scan that and you can get a quote. There is a contact form if you're interested. There's an audit and we can talk about it. So if you have AWS that you are unsure about and you want me to take a look at it, I'm happy to do that. Gonna give it a couple of seconds. Good. So the state. So everyone, whoever is engineer in this room, and probably even non-engineers at this point, we're all aware that state is one of the core concepts in engineering. Now the states are also the agent engineering concepts, because the thing is that we all know that state can change and it can alter the way that our platform and our application reality behaves. So what I mean by state, API calls, post requests, we have model changes, context changes, we have different parts of the platform that would change because of some action that was undertaken by the user. So now that output will become a state when a model now connects to our platform. So when we are talking about humans in a normal sense, when we connect to our tools, we as humans know that the standard process of mutating a state is, well, we have someone responsible for something to be changed on the platform, we have like separation of concerns, we have a platform team, we have DevOps team, we have engineers, backend, front-end, everyone in the team. There's a business decision calls, and there are different teams like that. But when an agent integrates into that process, do we really know how to handle it, or are we going to be scattered across the system and just gradually allow that state to become overpopulated with actions from the agents? So this is what I outlined to myself as the core model output state model. Basically, the model starts as a text. So we input some prompt, model spits something out. We get that model output. Then happens the tool call. So the tool call can go to our MCP server. We can have separate MCP servers. We have agent runtime that can access both of those contexts, and we can call further the capabilities of the tools. Then goes the API request. So some kind of operation starts and executes, and something happens in our system, the state changes. Then once it changed, the mutation has happened, and now we don't know, unless we have some trail, what has exactly happened and what agent or what actor has now changed this in our system. So if it was a record in a database, how do I know as an engineer that this has been changed? And then comes the evidence. So evidence, when I will come to it further on my presentation, but when I talk about evidence, I don't just talk about the trails, I talk about the responsibility. So who is responsible for what action in our system now? Because human actors and agent actors are different entities, because we're talking about the natural intelligence, the human intelligence, and the artificial intelligence here. And the canvas is really big, because the human nature is that we have a person who comes to work every day. If they do something wrong, they can be regulated, like in a form of firing or in a form of disciplinary actions and stuff like that. So we know how we can enforce this. What happens to an agent? We can't fire an agent. Not really, like we're paying for it to be there and to be integrated in our system. And now I'll go to it, I'll come to it, but there is a new timeline, like agents are no longer just text editors, like they're not just suggesting engines. They have the autonomy. And with that autonomy comes the lack of evidence that we can provide for us as engineers to also review it. And the evidence needs to support a couple of things. So what can be revoked? Who can be granted access? What grants have we got already? What have we changed from week 1 of our sprint till the end of week 2 of the sprint? Can we disable a tool if we needed to? Can we roll back fast enough to avoid further damage in our system? So agents are becoming, they have already become an execution layer. Like, it's no longer just the text editor. We're not talking about the chatbots. This is like so 2015. Agents are now executing the actions on the platform. So like IAC, like infrastructure as code, we're now integrating them at the point where they are autonomous actors within the system. And the worst part is we can't see them going, grabbing a coffee, and we don't see them working. What are they doing? And it's all down to us as platform engineers to now find out how we can trace that trail of what they have done. Agents, it's not even a life form. So we're now moving from the suggestion in the code editor to the actual intelligence inside our platform. So this is a timeline I really like to think of as a kind of the latest of the evolved agents, like a couple of years. Obviously, artificial intelligence dates back to the 90s. Even to the beginning of the 20th century, if we're talking about the algorithm for it. But when we're talking about 2021, if you remember, what happened was that we got in our WebStorm and our Visual Studio codes, we got the suggestion tools, right? So we could pair program with it, because, I mean, it wasn't really a tool that would talk to you and say, oh, don't worry, your code is going to be fine, your platform is not going to fail in a day, I'm not going to delete your database, nothing like that. All we had was, I'm completing a function for you because this is how it's supposed to be done. Then we go to read the docs, and that's how we finished the autocomplete. Great. Everyone was so happy when it could complete the lines of code with the exact thing that I was going to complete it with. So, but it saved me time, and I could review it easily, fast enough. Great. Then we evolved into the chat when they started negotiating with us, when they started explaining themselves. Agents I'm referring to. We are now we're convoying with those chatbots. We're talking to them about our problems in the code, how we're executing something. And then it grew kind of to the call tools, which are now calling the functions. They are doing the calls in the system, but they're still somewhere separate. They're still only agents that are integrated as third-party tools. Great. Then we have connected them through the MCP service. It became really popular, even though MCP protocol was existent way before 2020s. It was in 2018 that it was created, but the MCP service became really popular at that point, and the multi-agent workflows where we had different actors as agents integrated between each other and executing different functions based on the context. And then we started last year to execute those in our PRs. We started to give them the A2A, the authentication workflows. They can now use the token and get through everywhere they want in the system, which gives them pretty much a lot of autonomy. And here we are now in the infrastructure layer where they completely like separate tools integrated in our pipelines. And if we're not securing them in terms of the access control, then they can execute whatever they want in their agent runtime, in their identity-wise permissions, and the payments. Imagine having to refund some user a particular amount. You have policies, but you haven't really defined to an agent what the policies are going to be about. You just prompted it. Prompt is not a security measure, by the way. It's just a spoiler. But yeah, it's not a security measure at all. When you don't have a token guardrail, that is not going to work. And I'm anticipating that in 2027, and by the beginning of 2027, it's going to become more of a governed authority, which is great because this is a policy-driven execution that we're moving towards. And I think that is the ultimate way to go to. So yeah, connection is not control anymore. We connect tools, and we need to now start enforcing the permissions for the tools that we connect. So the problem is that the AI agent has access to the multifaceted platform that has different tools, that has scopes, has code and platform measures since 2012, and it needs to also decide based on the context. The problem is it doesn't always have all the context. So you can have prompt instructions, as many as you want, you can have CI secrets, and then there are API keys that you want to keep secure, and you tell it to keep it secure, but then your token actually allows the AI agent or the entire MCP server to just have one token for all of those actions. So now it can access all of those small different scopes, and it grows into a big scope, which is a really bad idea because we're not controlling the AI. We're just giving it access and grants to every single part of our ecosystem and letting the business know that, okay, we have AI now, but what does it do? Well, it can do anything it wants to. And if it drifts, then who's going to be responsible? What is the audit trail there? Which is what I'm trying to say. So orchestration. Before, orchestration was a platform engineer occupation. Basically, what we do is we create automation on our platform in different ways. We can do Kubernetes clusters automation. We can do the policy checking. We can do our CI/CD checks. We can do PR runs. So many services on AWS we can spin to just orchestrate the whole entire platform, the network-wise, the code. But the problem is that now AI can take part in that orchestration. So if we don't have the proper approvals model, and if we don't control the state changes based on the actions, the exact audit trail, the 1, 2, 3, 4, 5 flows, then now we have a problem with the workflow. So the workflow typically is this. So we have a task that we want to fulfill. Obviously, till we go to the evidence point, there is a number of steps that we need to undertake to do that. So, okay, we connect our agent to our tool. Great, it can now execute some stuff. Then we want to plan for the model, like what do you need to do? Like give the exact instruction, and then it starts retrieving, checking policies, calling the API. That is a great flow, unless you have a drift in your system. So if you already created if you already created the enough permissions for the AI tool to execute different parts of the application, you might be at risk of over-granting it the permissions. So what do you do in that sense? You have to provision for a better controlling point in the excessive agency. So at this point, we want to, instead of having broad tools that can do many different things of application, and they can control, and they can alter changes, and they can also review and be autonomous in the system, like no longer just suggesting to the developer or platform engineer to do something with the platform, but actually approving PRs, actually releasing code, actually making the changes to the platform, like CI/CD pipelines, without the knowledge of engineers. Unless something goes wrong in production, we are not aware that it was badly refactored or just drifted somewhere astray. Yes, obviously, it can do code correctly. Obviously, we can count on it to use some pattern that it already has in its system. Yes, but can we really observe what it's doing? Like, can we really see what the calls trail was and how the PR has changed and what did it approve and did it not approve? So now we come to that part where the record that we want to keep is of every single action that the agents do. The problem with the MCP servers as well is that even if you have two MCP servers where you don't grant permissions to run between each other, you still have the agent runtime between which they can share all the actions. So you have API, essentially, that they can access and run and coordinate the tools, whatever they want, really, at that point. So yes, prompts are absolutely not permissions. When you're writing a prompt, did you notice that you're writing it in English, right? So it is the people's language. It's not the way machines are interpreting it. Yes, it can persist it in its history. It can add it to its memory. Of course, it's great. It may control the behavior, but it's not gonna be your sole boundary. It's not gonna be the boundary at all. It might do it for the first 2 runs if you even like test yourself. But once you give it an instruction, that would be like it will precede, essentially. It will create some new context for it. It will then be overwritten, and your prompt will essentially just be useless. So the capabilities of the tools are what you need to care about. The things that you permit. So the 2 things that are the best boundaries would be the token and the scope. So no matter how much you want to prompt it, no matter how much you want to do something. So imagine you, for example, want to review a PR. There is a Jira ticket connected to that PR. The agent goes, checks out the ticket. Maybe the ticket says some instructions to use some other third-party tool. The company has not authorized to do it. So you go in against the policy in the company to allow the tool to execute something. And AI absolutely loves to scrap from the internet whatever tools it can to foster the faster development. I've seen NPM libraries for numbers. Literally, NPM install numbers, and instead of using the 1, 2, 3 from some other file, it would use the functions. That would be the numbers, finding out the numbers from the functions. Great. I mean, this is just one of the examples that, but the tools that it can use, the capabilities are not really the ones that we are looking for. So if we are granting the token that can write and read and do whatever, all the permissions that we want just because we want to deliver faster, and I've seen that happen. So startups these days, they don't really look at, not all startups obviously, but some startups, they don't look at how secure their platforms are. What they're looking at is to deliver as fast as they can for the investors, for the business, to get some money and stuff like that. Then they will spend that money obviously on the incident solutions, because incidents are most cost demanding issues that happen to the platforms. If you don't have a cyber incident, you'd better invest into the audits and try to go through all of the permissions that you currently have on the platform. So the capabilities that you're granting to your agents are the tokens that you essentially have provisioned. For each tool, you need a separate token to make it secure. Otherwise, you just have one token with all possible grants, and it can now perform whatever actions it wants to. So yes, we need an explicit contract with the agents, because we need a way to control them. The boundaries, the scopes, the environments that you want to use, you gotta be really careful with the approval model for them. So this is an example that I wanted to kind of show today, because this is the typical definition of the roles, the scopes, the things that we need as engineers to define at the bare minimum. We want identities, we want actions, environments in there, but we need to have evidence for each. So when there is an environment, obviously, dev environment is going to be the same as the prod environment. In production, we want to stay away from the secrets. We want to reuse them from somewhere else rather than doing it directly. And we need to understand at what point who accepts the risk. So we can't obviously trust the model to accept the whole risk for it, because there will be a person in the organization who would be responsible for this. So when a business defines some scope for the action, then we grant that action to the agent, and we define a scope. Then we go further. 6 weeks later, we have another scope defined. Now, we have drifted from the original scope. Do we know that, or have we just granted it a couple of more capabilities? Yeah, in the first weeks, it was check the PRs. In the 6th week, it was, okay, just rewrite the entire Kubernetes clusters and just set it up so that, it's efficient. Did we just grant the over-promising capabilities to the platform? So the evidence trail, the approval process needs to all happen gradually as we go to create new permissions. So the actions that we grant to the AI, we need to make them explicit, as we would do with APIs, as we would do with code. So we need to validate before we do any merging. So the PRs is the basic example, but we also have database migrations. We have editing that is involved for the legacy code. Agents are really great in editing the legacy code. However, we need to make sure that the business logic doesn't drift. So every time it suggests a new change, we also have to monitor it and we have to approve it. So this is one of the things I like to think about. So basically we have the new tool scope defined first. This is where we allow it to change the PR. Then we want to see what the risk is the new PR going to pose to the new system. So we want to scan against any drift from the original permissions, policies. So you see like where I'm going to, it is going to be more time-consuming, more token-consuming for AI to actually review what it did, rather than just scanning, for the code itself and trying to classify what it has done. Because now we want to assess the risk clarification. That's why I'm not showing you a bunch of code that would help you to execute the policies. I'm talking about the business define the risks connected to the AI usage, and then now we want to classify it. What is less damaging, what is higher damaging, and what is the destructive actions that we want to really be aware of. So destructive actions are what we're trying to catch out here, because things like delete a database, like drop the table, drop the whole database, these are the destructive actions I'm talking about. So the policy check bit, the reason it's yellow is because I really want to stress this, that we need to be able as humans, as also implementers, to allow, deny, or request more evidence trail. Even if we have an agent that would be doing that policy check, we now need to go further with the trails, and we need to present the black and white evidence for those agents. And then it comes to the decision trail. Obviously, we can't trust AI 100%, but we can be sure to some extent where this decision trail is going to take us, and then obviously merge or block. But we can't block everything. That's why we need a controlled outcome model that will help us to see where the owners are missing, who is going to be responsible for what, where is the approval is missing, and stuff like that. So. But yes, drift is what I'm trying to get in this talk, because we want to essentially be able to grant the access to the agent that will be looking after that drift. Because what I'm talking about is IAC, but agent as code. Agent tools as code is an interesting concept, but this is happening. Like we have in our organization, a lot of MCP tooling that takes care of many platform things, that like reviewing of the PRs and reviewing the policy checks constantly. Like every day it would check how much the policy fits what we are doing with how we're doing and what new tooling we have implemented, and it triggers the checks. So we need to understand the approved contract and tell it from the live reality. So for example, if we want to read the GitHub access, and then we want to also grant it something that it would do based on that access, like we're now granting it a write permission, we want to understand which tool will be enabled and what tokens it has, how the scope changes, and what needs to be approved further. So it needs to be the same as we would do with humans. So you have CloudWatch that helps you track what people have accessed and what time, how much scope did they have, are there admins in the system or are they just users, stuff like that. But it's no longer just role-based access, it's agent-based access. It's the way you would define. And the problem here is not that you would have two agents communicating or even one agent. The problem is that there are tools and teams scattered across organization, and there will be a complete mess when there is 5 teams trying each to implement its own MCP server, and then tooling within that server, and then interconnect them in between each other, and then it starts drifting. It will be a different reality from the approved contract, so the company can approve one thing, but then in the teams it would be a complete different reality, and the production is not going to be the same as what was planned originally. So that's why we constantly need to review the policies. We need to have some approval process. Policy is the key here, basically. So auditing is what I do, and auditable access means that I can go without thinking myself, without going to Jira, without going to GitHub PRs, without reading any messages in Slack, straight to the auditable trail, and I'll show you in a demo in a second. But what I want to do is I want to move throughout that chain. So before we had everything manual, then we moved to documented stuff. So some developers document things, and it is useful, but let's be honest, who reads the docs, right? Like, who would sit through every single part of the platform and read the entire documentation on and on and on again? It's much better to once upload it to the agent and then let it scan based on that all the time throughout the same document without drifting anywhere. Then we are moving into the versioning, then we're validating, and now we want to move into the monitoring and finally to being auditable. I don't want to go and read and collect the whole system's trail across the system. I want to be able to just go in one place, in my PR, for example, and see everything that it gets me to, like everything that it has done, the decisions that it was making along the way. So the same as typically the model will go through the phases. It will go through the decision-making process. I want to see that decision-making process with the facts and with the code from the system that I can click on and go to in that particular period of time. So we want to do essentially mapping to tools. We want to make sure that we understand what agent has access to what tools and where it has that access. Does it have access to all of my pipelines, or every specific agent will have a specific pipeline assigned to it? I want to see hashes. I want to see the trail that will bring me back to that specific agent and not like 5 other agents. There are always in the systems that I review and see like 5 different things, and one is the one that works. So it is very, it's a poor setup where you have 5 different agents, but you can't tell apart what agent does what. It's not about naming them. It's about like making sure I understand the scope of every agent. I don't care if it's just numbers and some characters, but I really want to make it auditable so that if I click it, then I go to the exact scope it has. So it needs to be defined. Permission contracts are an important part here because we want to make sure that the context doesn't get away from the original defined by organization, by the business people who don't care about your agents, but they need to be able to be in charge in those permissions. Because we want to not allow the different agents from different teams to access all of the contracts just because it's easier. We like to all grant at first, when we're testing something out, let's just do, for example, like in an IP, I'd put all zeros so that I can access it from anywhere in the world, so I can check that it works first, and then I'll do it stricter to my own IP and I will reserve it. But the permissions are there for a reason, and that's why we need to block certain permissions, and we literally need to reject them. CI is another tool because it's very tricky to set up a perfect, optimized, the least money possible costing CI pipeline. And that's why any risky changes, and we need to define those risks that are suggested by the agents, need to be completely, challenged every single time. So it's the same as like keeping up with the system as it would be. So agents can now generate code in seconds, right? Agents can generate policies in seconds. Can we keep up with it? As engineers, as platform engineers, can we keep up with their speed? Can we really integrate a tool that would be matching our speed of the team, or are we not yet mature like that? So detecting the drift, obviously, across the MCP servers is one of the biggest challenges here. But obviously, not just defining the contracts, not just defining the agent permissions, but also do the cloud configuration overall, like making sure that your services are all scoped out for the agents. Yeah, so this is essentially that for the talk. I'm going to show you the demo now to basically demonstrate how this works in the real stuff. So in the real system would have, this is basically a control demo specifically created for the showing the approval context. So this is our PR denied denied, basically. What we want to do is make sure that it has the correct access. So here the permission it's asking for is to write into the PR. So these are the approved contracts that we approved as humans and along with other agents. This is the proposed life change. So it wanted to release something new. It wanted to release an action. And there is no expiry. There is not clear approval reference. So there is nobody to trace back to approve. That's why we deny it, because we want to make sure that we're not approving something that has missing data. Yes, it sometimes looks like a form where, essentially it asks for some weird detail that we won't need further. But what if this happened and then after that there was a table drop in like 2 days? How can we trace it back to this if it was writing something and actually did it by accident because someone defined another contract? So then we want to add that approval step. So we want to require the evidence. We want to satisfy or deny some evidence that we have requested previously, and now we want to see the expiry, the approved by, the approval reference. Once we have those details, once the agent went and fetched them, because sometimes they hallucinate and they just it just doesn't generate it. It just doesn't fetch it, because at that point it just lost the context of it. Now that we want to request it, we went and requested it, the process has started. Now we can allow this with evidence. And then obviously this is a kind of drift that can happen. So we have denied the read actions there, and we also want to match with the live context. So the live contract, again, the approved contract is there, and we want to make sure that this evidence does not drift away. So if we want to have some documentation there, if we want to have the result in a particular shape and form, we can't just grant it everything, like all the permissions that are existing in our system. So if we get it a write or read access, we want that particular access to continue. So here, if we are, instead of reading, we're getting a write access, it needs to be detected as a drift. So the drift will now be fixed in the system. We know that there has been a drift detected. Now we can review this with another agent if you wish, and we can now implement another policy that will be recorded. Essentially, this is all about just recording the separate policies and building them on top of one another as we go and build our platform. Just because we are now integrating our AI agents as our platform tools, we're no longer just using agents as a helpful third-party tools. We are making sure that they have access to some important bits in our applications. And it gets really ugly when we give it access to database with clients, payments, ability to perform actions such as refunds, payments, salary, outgoings, and calculations with critical business assets. This is where it can go adrift, and we need to make sure that we can audit it. And once we can audit it, it will be potentially a reversible action. But for now, I wouldn't say go and rely on agents unless you know how to set up the MCP servers and toolings in an appropriate way. So yeah, that was the talk. I really hope you got something useful today. And if you have any questions, feel free to ask. Also, if you want, you can also message me on LinkedIn after the talk if you're too shy to ask a question now. Thank you.